Hello grade 10 American System, this is Mrs. Nancy and today I'm going to start a new section in chapter 12, the arithmetic of equations. Please open your books page 386, balanced chemical equations. Chemists use balanced chemical equations as a basis to calculate how much reactant is needed or how much product will be formed in a reaction. So the calculation of quantities in chemical reactions is a subject of chemistry called stoichiometry. Chemical equations. A balanced chemical equation can be interpreted in terms of different quantities including number of atoms, molecules, moles, mass, and volume. So we are going to start with the number of atoms, taking an example ammonia. Ammonia is produced industrially by the reaction of nitrogen with hydrogen. So at the atomic level, the number and types of atoms are not changed in the reaction. This means that the reactants are composed of 2 atoms of nitrogen and 6 atoms of hydrogen, and these 8 atoms are recombined in the product. Number of molecules. The balanced equation indicates that 1 molecule of nitrogen reacts with 3 molecules of hydrogen. Nitrogen and hydrogen will always react to form ammonia in a 1:3:2 ratio of molecules. Also, you could take Avogadro's number of nitrogen molecules and make them react with 3 times Avogadro's number of hydrogen molecules, and the reaction would form 2 times Avogadro's number of ammonia molecules. Moles. The coefficients of a balanced chemical equation indicate the relative numbers of moles of reactants and products in a chemical reaction. In the synthesis of ammonia, 1 mole of nitrogen molecules reacts with 3 moles of hydrogen molecules to form 2 moles of ammonia molecules. Mass. A balanced chemical equation obeys the law of conservation of mass, and this law states that mass can be neither created nor destroyed in a chemical or physical process. So as I said before, the number and type of atoms does not change in a chemical reaction. Also, the total mass of the atoms in the reaction does not change. So, we start. The mass of 1 mole of nitrogen, which is 28 grams, plus the mass of 3 moles of hydrogen, which is 60 grams, equals the mass of 2 moles of ammonia, which is 34 grams. So, the total number of grams of reactants does equal the total number of grams of products. Volume. As we studied before, 1 mole of any gas at standard temperature and pressure occupies a volume of 22.4 liters. So, the equation indicates that 22.4 liters of nitrogen reacts with 67.2 liters of hydrogen, which is 3 times 22.4 liters, and this reaction forms 44.8 liters or 2 times 22.4 liters of ammonia. Sample problem 12.2. The balanced equation for the burning of hydrogen sulfide is the following. So interpret this equation in terms of part A, number of representative particles and moles, part B, mass of reactants and products. Let's start with part A, numbers of representative particles. According to the balanced equation, we have 2 molecules of hydrogen sulfide plus 3 molecules of oxygen forming 2 molecules of sulfur dioxide and 2 molecules of water. Also, interpret this equation in terms of moles. We write 2 moles of hydrogen sulfide plus 3 moles of oxygen forming 2 moles of sulfur dioxide plus 2 moles of water. Part B, interpret the equation in terms of masses of reactants and products. First, you use the periodic table to calculate the molar mass of each reactant and product. So 1 mole of hydrogen sulfide is equal to 34.1 grams. 1 mole of oxygen molecule is equal to 32 grams. 1 mole of sulfur dioxide is equal to 64.1 grams. 1 mole of water equal 18 grams. Then we multiply the number of moles of each reactant and product by its molar mass. So 2 moles times 34.1 grams per mole plus 3 moles times 32 grams per mole forming 2 moles times 64.1 grams per mole plus 2 moles times 18 grams per mole. The answer is 164.2 grams. The mass of the reactants equal to to the mass of the product, which is 164.2 grams.